Hello, and welcome to the design of experiments and multiple industry processes to reduce lead times and defective rates. I appreciate you coming. We're going to start the presentation now with a little bit of logistics and housekeeping discussion, and then we are going to start into the webinar. This webinar will last just about an hour, but that includes some question and answer time at the end. We may go slightly over an hour if there's lots of questions. Do not be concerned about that. There is a lot of material, though, and we will not be able to hear you. We have muted your input, but I will be watching the text entry, so you may use the interface with GoToMeeting to type in questions for Forrest. I will share them with them. Please do that as it comes up. If we cannot answer all of your questions, we will call you with a response if you need. Plus, at the end of this webinar, you may be contacted by a person from Smarter Solutions. If you do not wish to be contacted at the end of the webinar, you'll have a chance to opt out of it. There will be a recording of this webinar in about 4 to 8 hours available on our website, and you will get an email that shows you how to watch it again if you want. There is also at the end some feedback on how the webinar went and how you felt about it. Please fill that out. It helps us with our understanding of what we're providing to our customers. I will now introduce Forrest Breifogel. Forrest is a CEO and president of Smarter Solutions. He's a professional engineer, an ASQ fellow. He serves on the board of advisors for the University of Texas Center for Performing Excellence. In 2004, he received a Crosby Medal for his book, Implementing Six Sigma, second edition. He has also authored or co-authored 13 books, published well over 100 technical articles for well-known and worldwide publications. He recently published a 4-book series on integrated enterprise excellence, which I would say is better than any of the books he's put out so far. But again, thank you for joining us today. At this time, I will turn the presentation over to Forrest.
Okay, just like Rick said, we're great to see that you're signed up for the DOE webinar. So I'm excited about talking about design of experiments. I got a passion for the topic since that's what really got me into this whole field. So basically, we're going to be talking about 5 different topics in this session. The first one is why actually use design of experiments, and what's the advantage of them over what we call OFAT, one factor at a time experiments. Number 2, I want to look at the application of DOE within an overall business management system. I think this is one of the things that's often missing. In the training I've seen so often, we get into the mechanics of it, but we somehow lose sight of where do we really apply it, and how do we use it so it benefits the business as a whole. Thirdly, explain the benefits of using what we call 2K DOEs over other options, where you've got 2 factor levels and then you have multiple factors that you're looking at within experiments, because there's a whole bunch of different options that you can use. So we've got some preferences on that, and I'll explain why. And then one to get into applying DOE within various situations. So we're talking about looking at development, how you can apply it transactional, and manufacturing. A lot of times people just focus on manufacturing. And then we're going to look at how do you go in and look at DOE factors and levels within the product design, optimization and verification tests. So we'll still have factors and factor levels. However, how you choose the factors and factors levels and how you actually look at the response can have some different spins that are quite powerful here that nobody seems to talk about as much as I think they should anyway. The methodologies we're going to be really talking about in the session here, it really gets in a lot more detail in Volume 3 of the book that I have, and also the project execution guide that came out earlier in 2010. So these topics that we're basically going to be talking about is covered in more details in these books. So here we've got a a question for you. It's basically what your role is. So what I'd like for you to do is please select the role that best describes you so we can get an idea of who we're speaking to out there.
All right, the poll is open. Please select from your screen one of the choices. And we'll give it about another 30 seconds and we will close it and you will get to see what the results are. All right, it's looking good for us. It looks like a metric developer and follower of a metrics is leading. Oh, it's changing here. I guess this is like any poll. People respond. We'll go about 5 more seconds here. All right, I'm going to close the poll. Thank you for that. And the results should, there's the results. As you look forth, 31% of them are metric developers, and the same for people that follow metrics. So we got a lot of people that like metrics right now.
Okay.
Oh, I gave the wrong poll, Forrest. I did the wrong poll, but we'll come back to that. Let's give the other one here. No, we're okay.
Okay. So now what we're going to be talking about is aligning these design of experiment methodologies to the techniques, the business system that I put together in the books called the Integrated Enterprise Excellence. And one of the mainstays of that overall system is that you need to start out with what you do and how you measure what you do, as opposed to having strategy is basically step one in your overall process of how you're running the business. So what I put together here, what we talk about in the Integrated Enterprise Excellence System, is the value chain. So basically, we're looking at the voice of the customer, develop a product, market product, and so on. And that's basically what you do. And that's represented as rectangular boxes, and you can have drill downs to get the individual procedures. Now, the oblong areas represents the different measurements that you have. So now, if you look at your measurements, then we've got an example of one that's here where we're looking at the on-time delivery. Okay, now, if we track it over time, we see on the left-hand side where you have this 30,000-foot level control chart, we'll look at and say the process is stable. Now, if it's got a recent region of stability, we say it's predictable. The next question is, what do you predict? Well, you could put the actual raw data in the latest region of stability, put it on a probability plot, and then look at your spec. So in this case, we got minus 5 days or 5 days early to 1 day late. So from this, we then say it's a predictable process with about a 14% non-conformance. Okay, now, if we would like to do this for all our metrics that we have, or all that we've listed in the value chain, and we're going to figure out which ones we're actually going to be working on. Now, if we don't like what we see on this, we need to go in and change the process. Okay, and that's what we're looking at too, is how we're going to change the process, or how do we gain understanding about our overall system to figure out where we should focus our efforts. And DOE is one of the tools that plays a role in that overall effort. Now let's look at one that we have with attribute. Okay, in this case, we're looking at a pass-fail situation, and we notice it's got a shift. So in the latest region of stability, we look at all the data. We say the process is now predictable and produce an approximately 5% non-conformance rate. So again, if we don't like this response, then we need to work on what we're going to do to improve it. Now, I'm going to be approaching the design of experiments with a philosophy, if you got a hammer, don't make everything a nail. So I'm suggesting design of experiments is not necessarily the best tool to use for every situation, and there's other tools that could be considered along the way. Now, just to reiterate, the rectangle boxes describe what you do. So those are basically processes. And those processes also give you an output, or Y. So the oblong box there represents the output of the process. And now the inputs, are the X's, is what can affect how well the process performs, and also the process steps itself. So it's important that everybody understands Y is a function of X.
So the output of the process is a function of the inputs to the process and the process step itself. Okay, now let's consider we looked at all our metrics together, and we decided there's certain ones that we want to improve upon because it's the right thing for the business as a whole. Notice when we look at everything together, we get out of the silo mentality. Okay, now if we look at the inputs to a particular process, we might have differences between departments, suppliers, machines. Now, if we're going to look at that and try to understand and see if that makes a difference on the output of the process, we can use analysis of variance techniques to help us gain insight, or analysis of means. Now, if you've got continuous type inputs, temperature, pressure, and so on, then you can maybe use regression to go in and help you gain insight to what you might do differently. Now, both cases here, we're looking at things passively. Okay, so we're not actually doing anything to the process, we're just observing it. Now, we need to understand that if we're making improvements, just by setting goals to make those, to meet objectives doesn't make it happen. We call that management by hope. But just by understanding what drives the output of the process doesn't make it better anyway, is what you really need to do is to go in and look at these inputs, and then hopefully that gains you insight to what you might actually use differently. Now, analysis of variance and regression techniques has advantages. You know, we don't really have to go in and do anything to the process, we can just observe it. However, there's some, pretty strong disadvantages too. Is regression, for example, might not indicate that, for example, temperature is important within a process. Well, because of that, we might not look into adjusting or changing the temperature of the process because we think it's not important. But we could be getting fooled because if we change the temperature to beyond what the normal operating range of temperature is, then we might find out that temperature is significant, again, if we go to bounds that are beyond what we normally see within the process. Now, the limitation of regression and analysis of variance is overcome with the 2K design of experiments. So in 2K design of experiments, we're going to have K number of factors. So we could have, for example, temperature could be a factor we're looking at. We could look at pressure. We could look at two different machines. Or we might have operator A versus operator B, or have a different cavity in a mold, cavity 1 versus cavity 2. But in this case, we're looking at just only 2 levels that we're looking at. So that's what we mean by 2K DOEs. Now, George Box, who's been considered a guru of the overall methodologies of design of experiments, he's kind of says, in order to find out what happens in a system, you really need to infer with it, not just passively observe with it. Well, with looking at regression analysis of variance, we're just passively looking at it. So 2K DOE gives us an opportunity to so-called kick the process to determine if it might make a difference. And now what we want to do when we go in and use these techniques, we need to have a structured approach to actually handling that. So now 2K DOE analysis can yield significance tests for the factors levels. So the idea is we can say, well, between high and low for temperature, we can see that it makes a significant difference on the response that we're looking at. But in addition, it can provide a prediction model for the response. So now we can go in and predict what we might expect for a response at various temperatures. So what we're going to do with a 2K DOE, we're going to assume a linear output relationships as we go from low level of a response to a high level, a low level for a factor to a high level. So from low temperature to high level, we're going to assume there's a linear response. Now we can get a little more sophisticated and check that theory out. So there's ways to do that. That's not what we're going to be covering this time, but that's what you can do is check out that assumption. Now, if you have 2K approaches, 2K DOE approaches, you can have actually a full factorial where you're looking at all possible combinations of the input levels. Now, if you've got many factors, that can get to be very expensive to actually conduct that particular type of experiment. And in fact, you're looking at high-level interactions and things that don't necessarily happen all the time. So there's some other alternatives that make it a lot more economical, feasible, and there's some trade-offs on how you do that. But for right now, we're just going to be talking about fractional factorials in general. And so now we can go in and look at even 15 factors in 16 trials. So 2K DOE techniques offer an efficient strategy for a wide range of applications. You know, Forbes' article a while back described many different situations that it could be useful in. But again, I think it's important. We don't want to go in and force something that's not there, and we don't want to take on the let's make it a, you know, we got a hammer, make it everything becomes a nail. We don't want to do that. So as I was indicating, we could look at all different combinations. So this would be 16 trials as shown on the left-hand side. If you got 4 factors, you take 2 to the 4th power, you get 16 trials. That's all combinations. Now, if you look on the right-hand side, what we've got is we've got a resolution 3 design, and where we can actually look at 15 factors in 16 trials. Now, I prefer to use 2K DOEs, where we're either going to have 16 and 32 trials. Those are the ones I use the vast majority of the time. Now, you could run an 8-trial design, but let's think about that. Well, let me step back first. We notice that for each one of the columns, those represent a factor. So, for example, column number 1 might be temperature. Column number 2 might be pressure. Column number 3 might be speed. And then the output might be the quality of the product or a particular dimension on the product. If we know for these particular designs, we've got an equal number of pluses and minuses in each one of the columns. Now that creates a nice property. That's orthogonality in this particular design. So when we're actually running the experiment, we're going to run, for example, trial number 2 on the left-hand side. We'll be running factor number 1, that would be plus, plus, minus, minus, and we're going to get a response. Now, if we go in and look at how it affects our output, we're basically going to be averaging all the values that are high and all the values that are low, and looking at the difference. Now, if there's no difference, and we didn't have an experimental error, we'd expect a difference of 0. Now, if we've got a large difference, then we would maybe say, or if relative to air, then we'd say it's significant, or we'd say it's important. So factor number 3 might be important, that it might affect our output. So then we'd further investigate that. Now, if we look at the design on the left-hand side, we've got 16 trials, we only have 4 factors. So we've got all possible interactions. Now, what are interactions? Interactions are when 2 or more things have to work together to affect your response. Now, 2-factor interactions can be important, but when you start getting 3 and 4 and 5, it just does not happen very frequently in the real world. Now, if we look at the other design on the right-hand side, we've got 15 factors in 16 trials. So now we can go in and notice that, again, there's the same number of pluses and minuses in each one of the columns. Now, that has some nice properties to it. Not all design of experiments have those former properties. So a legitimate design of experiments might be to run something in 12 trials. Okay, and there's other ones, 24, and so on. But the problem that you have there is you don't have the equal number of pluses and minuses in the columns. And you lose information about these interactions. Now, on the 15 factors and 16 trials, we call that they're aliased together. They're mixed up together. And we're going to get into that in another webinar later, at another time. But even if we have this interaction aliasing with the approach that we're using on the IEE, we can actually start pulling things together or pulling things apart if we start blending knowledge with it. And we'll get together. We'll talk about that in another webinar sometime. But right now, we're really focusing more on setting up the experiment and how you go in and figure out where you can apply it to be most effectively. So with this integrated enterprise excellence approach to 2K DOE, we want to emphasize the use and efficient use of the two-level fractional factorial design in lieu of conducting a large full factorial design. Now we're going to be focused on continuous response, but however, attribute response will also be covered or addressed. Okay, we got another question here. Okay, this is one.
There you go.
This one we already covered?
No. Yeah, here's the, everybody should be taking the poll now. It's about what's your primary reason for participating in this webinar. You'll see we have the continuous education, more DOE information and such. It looks like for us, we got two that are leading the pack right now. So I feel like I'm calling a race.
Okay.
But as we're running through here. This is always interesting. This helps us at Smarter Solutions understand what we might want to do for our next webinar. So we appreciate your input. I'm going to close the poll here in about 5 seconds. All right, here we go. And it looks like, Forrest, where'd it go? Come back up. It looks like, Forrest, that continuing education and looking for the enterprise business improvement ideas were the two leaders. Oh, there's 3 leaders. I just can't see the colors well. Current business project use using DOE, so it looks like a varied group of people and what their needs might be today. Looks like you have a lot to do to cover all this. Back to you now, Forrest.
Okay, great. Okay, good. Thank you for your assistance with that. Okay, I wanted to elaborate more on the two-factor interaction plots. Okay, now let's consider we've got, and that's what I remember I was talking about, all this interaction confounding and so on. And that's what we're giving up whenever we change or move from actually looking at 4 factors in a particular design to 15 factors in a design. So but what might we have? Well, let's consider we got a situation that we want to have the speed of photoconductor to be the lowest that we can get, or might even have a specification to it. So what are we going? We're going to look at 2 different factors. In this case here, we got bake and we got additive. Okay. So now we've got 2 different levels for additive. One of them is this, and another one's this. Okay. So we've got additive could be at 1%, or it could be at 3%. Now, if we get it bake, it could be at 55 degrees, or it could be at 45 degrees. So what are we going to start with first? Okay, well, we'll probably start with first is doing the cheapest one, right? So this would be our cheapest one right here. So what did we get? We ran, again, 1% additive and then 45-degree baked. So what did we come back? And we got this particular response. Not a very good straight line there. Okay, so then we said, well, let's go to the next least expensive, and that's number 2. Whoops, it looks like we got an increase in the speed of photoconductor. So guess what? Additive, 3%. Let's don't go with it, obviously, because we tried to increase the additive 3%. It didn't make a difference. So now we go in and say, well, let's try it at a different temperature. It's a little more expensive, so we try it over here. Oh, well, it made it lower. Okay, so guess what? We're going to go with this, right? So we're going to go with 55-degree bake and 1% additive. Now, this is called one-at-a-time experimentation, and it happens all the time. But we didn't look at the other combination. If we would have, we'd have noticed that, yes, it's more expensive, but it made a better speed of photoconductor response. So that's the purpose of that's what an interaction is about. Now, if you're going in and designing an experiment, what we want to do is we want to be able to manage our two-factor interactions. Now, some experiments, when we're talking about Plackett-Berman designs and these certain other experiments, we're not really managing them. But if we do 2 to the n, we are managing them. So 16 trials and 32 trials, we are managing them. Now, they may be mixed up. For example, factor A and B interaction may be mixed up with D and E, so we have to be careful of that. But there are some things we can do to address that. And we can do a multiple experimented approach, and also there's other things we can do by blending in wisdom of the organization. So that gives you a little bit of an idea of what we have on this. Now, let's go in now and move into how does this apply to the overall business. Well, in the IEEE approach, we talk about, we create a business system that we get into and the roadmap for that is an E to make roadmap. So what we want to do is define what we do in this business system, measure it, analyzing it, and then improve it and control it. Now, gee whiz, guess what? If we had any problems with control recently in the business system, well, I think our oil spill, in my mind, is an example of something that didn't get controlled very well, and all of a sudden there's a catastrophic kind of problems. And I think we can see that happen a lot of times in our overall business system that we've had. Our financial crisis is part of that. So that's very important. But before we get into that, we look at improve. Now, how are you going to improve? Well, you could go in and improve an improvement project, and you'd follow the P to make roadmap here. And that's often, related to Six Sigma. We got to the make roadmap. Now, this is for project, again, on this part here, and this is for the enterprise. So I've put together this for the this IEEE system. So that's unique to this. So we start with define, measure, and then I got some additional drill downs here to better elaborate what you're doing in the measure phase. Now you analyze it. Guess what we're doing here? We're doing some of the things that we talked about previously, where we can look at regression, analysis of variance, that can gain us insight to what we want to do. Because what we're really trying to do is improve the measure response. And that's the baseline that we got right here, the baseline that we have here. In the analyzing, trying to look at analysis of variance and regression can give us insight to what we might do to actually improve the response. Now, when we move to improve, we've got some other tools in there besides we're actually putting in IEEE roadmap some lead tools. But in addition, we've got design of experiments as an opportunity to give you insight what you might do to improve. And then you go in and control, and you move back over here. So that's the basically roadmap. Now, where does DOE fit the most? Well, it's fix and improve, as I mentioned. Now, if we look at the design process and we're designing a new product, we can look at the MADV approach and measure, analyze, and design, and verify. You come back down over here. Okay, so now the question gets to be, how can design of experiments be utilized in various phases of this overall roadmap? So this is what I've put together here, is to kind of illustrate that. Now, this is not saying it's the only place, but it's a place that organizations can find very beneficial. Now, if we're going in and just working on process improvement down over here, then we can do a design of experiments in the improve phase of the project to make. Now, the analyze piece might have given us some insight to what factors we choose. The mechanics of design of experiments is not that difficult, but the key thing that's so important that we often lose sight of is how do you pick the factors and the levels of the factors. And when you look at and gain insight in the analyze phase, then that can help you figure out what factors and levels of factors are the most beneficial to look into. So in this particular case, we're looking at, it could be defective rates, or it could be a continuous response, a dimension on a part, or how long does it take for something to get processed, or whatever. Now, another application is in the design process. And I've listed 3 different areas that I think are applicable here. One of them is dealing with the define piece of the demand V, and then the optimization, then verify. Now, what I'm suggesting in the define phase is how you might be able to tie that to voice of the customer. And you might actually have different needs for different customers. So what you could do is end up looking at a response over here and then going in and seeing what you might actually do to actually go in and improve that response, or better understand that response from various factors that might be important to the voice of the customer. Now, another opportunity is in the design of the process itself. So we might be able to use design of experiments to help us optimize a process. Now, this could be development of a pharmaceutical product, could be a hardware device, it could be even software. How can we go in and twist things around and change things? Because one of the things that's different in design of experiments than the regression analysis of variance is what we really want to do is to go in and make some changes. You know, it's not just going in and look at things passively. So we could gain insight to what variables really affect our overall response and the quality of the product. Now, another opportunity is to verify. Okay. Now, when you're setting up the design experiment for a verify, it's a little different. Or I think it's very different, because when I worked at IBM, I used to do this a lot, is that what we want to look at is the factors that could affect the overall response, and what we want to do is set those to extreme conditions. Okay. Now this, and then instead, when we look at all of our outputs, we then can plot it, because all the factors are set to all the normal variations that you you would experience in the process, and then you could look at the overall response that you get for the 16 trials and do an actual probability plot of that response. Now, if that particular response is well within the specification, then you feel like you did a pretty good job. So you can see from the design process point of view of looking at the various, if the design of experiments would be part of the overall process of developing the product. And they would take a very different a way of looking at them when you're establishing it relative to the voice of the customer. That's one way. If you're trying to optimize it, that's a different way on how you look at it, and if you're verifying the process. Now, verifying the process could also apply to other situations also. If you want to go in and verify a supplier process, you could look at it similarly. So instead of going in and asking the supplier for 5 parts, what you could say is, I want to have 16 parts, and I want you to manufacture these parts where the settings on your equipment is to these different levels. So you might have 15 knobs within the overall process, and then you set them high and low, and those then you look at the overall responses of the 16 trials, and if those are all well within the specification, you feel really good. If they're not, then you could analyze it in more depth and might find that knob number 3 needs to be tightened up on its tolerances. So basically, you're not just looking at what the process is producing with those 5, 10, 20, or 30 parts that you're doing, where everything is pretty well constant, but what you're trying to do is make the process look like the boundary conditions that it would for future products that you're producing. Okay.
Horst, we have a question here, if I may interrupt for a minute. It fits well with where you are. I'm going to paraphrase it a bit, but it's along the lines that everybody teaches design of experiments for the Six Sigma projects, but not many people use them. Why do you think that's true? So here it is, Horst.
Well, I think you're hitting on one of the soapboxes that I've got, is I think that a lot of times and I'm not saying all of it, but the Six Sigma training is really gotten somewhat watered down a little bit too, and they're not getting into all the details and the power that you have with these particular techniques, and I think that's kind of a shame, because I think that DOE can be very powerful for many situations and processes that we're trying to prove within the overall Six Sigma project realm. So thank you for your question. Appreciate that. Okay, we'll move back here. Now, I just wanted to go in and give you a couple illustrations that are taken from my book. This is a real example. This was in development, so this was a verification test. In fact, this was dealing with an old, if you remember, the daisy wheel printers many years ago, and we're looking at the settle-out time of these daisy wheel printers, because if you didn't settle it out and you fired the hammy, which pushed the character onto the ink ribbon and then on the page, then it would bend it. So in this case, we're looking at the algorithm. So it was current design versus a proposed design. So I was the test engineer on this, so we wanted to go in and see if there was a difference, and that's what basically development wanted me to do. I said, well, I wanted to get more information. I wanted to see if there might be something else along the way that would happen, like could motor temperature make a difference, because normal operating conditions are cold to hot. But what about motor adjustments? Okay, that's something that you're going to be experiencing within the overall manufacturing process. It's going to be high to low. What about an external other adjustment that you might have that deflected the print wheels? What about the supply voltage? So all these conditions are legitimate. Now, we had, except for the B, algorithm, so now we got the current design versus the proposed design. So we really wanted to see a significant improvement in the proposed redesign. And so it had less settle-out. And so this is the logic I used for setting up that experiment. Now, in this particular case, you know, that, and I talk about in the book in more detail, is we found that the proposed design was good, and also found out that motor adjustment was also significant. So now you could go in and see if maybe you have to tighten up some of the manufacturing tolerances. So that's an example, and that we just wanted to kind of go over with the logic of choosing the factors and level. Here's another one that's from Volume 3. It's dealing with the testing of a computer, and basically you're trying to make one computer look like many computers. So we've got a different system type. It's compared new to old, so that would be something different. Now, you could have a fast versus slow processor. You could have large versus small. And these are other conditions that are legitimate within the overall test. So now you've done the various combinations, and then you look at processor temperature. Okay, now, and then the hard drive case and the video chip. So you're putting thermal you know, indicators on each of these devices and looking at the temperatures. Now, you could, instead of just going in and looking at seeing if factors are significant, you can actually plot, using probability paper, the temperatures, and then you go in and see if there's any particular combinations that might be causing some problems. Now, if everything is well within the temperature bound that's considered acceptable, then you don't have a problem. You can move on. So see how we can go in and verify the design. Okay. Now, this is a transactional process, so to speak. This is dealing with absenteeism of students in high school. Okay, so you go in and look at day of the week. Well, you could have Monday versus Friday, or you could have any day of the week. What about callback when absent? Well, that's a process change. We're trying to see if the absenteeism changes if there's a callback system to the parents when somebody's absent. What about school locations? Okay, well, you could have multiple school locations. What about class periods? What about mentored if they missed a great deal or not? Okay, so what about if you had a contract missed your classes? And then you got gender of students. Okay, now, if we notice, some of these factors are things that normally occur. You know, Monday through Friday, you're going to have different days a week. You're going to have different locations. But notice when we're starting to analyze and design of experiments, we're really not necessarily trying to go in and understand and model the universe. What we're really trying to do is gain insight to what we might do differently. So we might put the best school location as performed and the worst one. You know, class periods might be the best one and the worst one, and so on. So then we could go in and collect some data over time to these different combinations to see what kind of insight that we might get to change our responses here. So this is a transactional application. Hey, Rick, would you, we talked about beforehand that we've got a couple other applications that we've had people encounter during training. Why don't you talk to those?
Thank you, Forrest. This is Rick Haynes. We had two that recently came through our black belt classes. One was a master black belt, one was a black belt. One was with a company that provides the travel agent software for travel agents, and they had a goal to sell more cruises through their travel agents, and they did the design of experiments on how to show the sale on cruises on the screens, and they did different locations, top and bottom. They did size, they had the color, and they had something about the flashing or changing or movement in it for their design of experiments factors. And they did find a way to increase cruise sales for, I think it was 8-9%, by a certain way of putting it on the screen. We had a second one, which was a large electronics, I guess, retailer, but they're a net retailer, mostly through the web. They were realizing sales were down. They wanted to drive sales up. Their analysis, as Forrest had talked about, at the business level said most of their sales were from repeat customers. So the design of experiments was, how do I get repeat customers to repeat quicker? They set a goal of 90 days. They looked at different ways to make an offer to a sale. They did something in the box. They did it by email. They tried different offers. One was a discount on the next purchase. One was a flat fee savings for a certain size purchase. And I think the third one was offering them the same issue, but instead of just offering it with input on the product they bought. And they found that was a long one, as I recall, for us. They had a lot of people. They ran the test for 6 months and came up with a method to get more sales, and I buy from them. And I saw them change their reach out to me because of what I saw the results on the test. Those are two that have been in the last year and a half. All right?
Okay.
Thanks, Forrest.
Great. Thanks, Rick. Okay, so what I want to do now is to go in and look at some of the situations that you guys encountered. I sent out an email, asking for thoughts that you had. So a few of you answered, and okay, and comparing the fees we pay to individuals who work for us. So I went through these, and like I said, I think that there's sometimes that DOE is beneficial, and then other times, I'm not quite so sure here. Because remember, what we have to do is we got to either change something or not. Now, another approach is also, if we've got a lot of data, what we can do is go in and look at data that's either a combination of high and low levels. So it's going to be a lot of sorting through the data to actually create a design of experiment structure, but that's another possibility. Now, for the first one here, you know, they talk about comparing the phase where we pay to individuals doing work for us. And they looked at factors, distance from order, turnaround time, on late, and so on. They list several other factors. Now, it wasn't really obvious to me how you might be able to apply design of experiment for this situation, the way they defined it, unless they wanted to try to do something fundamentally different. You know, to me, that would be something that they might want to do. Now, the same person said they talked about the factors to include, but we cannot change the process to detect a few orders through changing the process. Anyway, looked at using the DOE. Well, just like as I said a few minutes ago, if we go back in the data set and actually can pull out these various combinations, you can actually build a DOE off of that. Now, the next one here, the third one down there, it talks about reducing the process lead time or cycle time in production and manufacturing processes. Now, in this case, they look at the output as yield, cycle time, processing time, defect rates. Okay, well, in this case, to me, it's really kind of almost a shoe-in to do this. And in some case, if we're looking at the DMAIC process, I might actually go in and jump into a design of experiment rather than especially if I don't have all the data readily available on analyzing it. But to me, then you could do things like they're talking about equipment A versus a V. You could look at the various processing parameters, temperature, pressing, mixing time, and so on. So to me, this would be one that would be very conducive to doing a design experiment. But you got to really be careful on how you actually conduct the experiment. And we're going to be this will be maybe a series of webinars on design experiments. It's pretty hard to cover everything in 1 hour. But how do you actually go in and reduce the amount of experimental error in your actual, when you're conducting your design of experiment? Because that's really what's important. Because remember, whenever we're looking at design of experiment significance, we're making comparisons to experimental error. If we've got a lot of experimental error, it's very difficult, if not impossible, to test for significance of some of the factors that could be important. Another one here is deliver education materials within a learning environment. So I think that this could be very good, that they're looking at e-courses versus modularizations and so on. And now those are some of the delivery types that you could look at, but it's also a function of the age, you know, how long has somebody been out of school and so on. And I would venture to say this one, you really got to be cognizant of interactions, because I would venture to say that a lot of times that what's right for one is not right for the other, because you might actually want to go in also looking at if you got some Myers-Briggs and things or some other way of looking at how that particular person learns. Okay? And the other one is talking about raw material cycle time reduction in the supply chain. Okay? Now, see, this is okay. Because now here, I'm not exactly sure if this one could apply or not. But I think in the supply chain, you can actually do use design of experiments I was leading to earlier to help you go in and determine how well the supplier is doing, especially when it's a setup conditions. Because one person here was talking about when they started going in and moving things to China and Mexico, and that they were having some issues. And I think there you can actually test it out real well to make sure how well it's doing.
Forrest, I have something I'd like to interject for a moment. One thing is I'm seeing these are good ideas that people put in, but some of it's not clear what the output is. And I think before a design of experiments, you must have a clear output of some metric that you're trying to change. Now we're going to be coming up on it. I don't want the audience to assume that means it's continuous data. Because you can do design of experiments with other types of data, even pass-fail data. When I talked about the one with the electronics firm, they had pass-fail data. They either ordered or they didn't. it uses the logistic regression techniques to analyze the design of experiments. So really, you can use it almost anywhere that you have a metric you want to, that you can decide what the best condition is from it, and you've got factors that may drive it. But I just want to make sure we don't think it's just continuous data. So here you go, Forrest.
Yep, no, that's a good point, Rick. That's very important. Now, another one person was talking about plating process improvement, and they listed the output. I believe. Let's see what they had on the output, because Rick was talking about that. Let's see, I'm looking through my printed hard copy here. I'm not being very green. Okay. Let's see, here it is. Okay. They're talking about, oh, here it is, risk of peeling, and then that was considered for the experiment procedures. That would be something that they might want to look at here. And then we want to look at how well it is actually performed to the specifications, I guess, also. Now, the other one here that was dealing with R&D, where can you apply it? Okay, they're looking at various output responses, looking at operational speeds, pressure control stability, and pressure rate controls. So those are all legitimate outputs that you might be able to have. The other thing that's important to consider also is that you can have multiple outputs for a particular experiment, because sometimes you might have to actually do trade-offs. You can't get your cake and eat it too, maybe, but you might have to do some trade-offs. So there's nothing wrong with that. It's a pretty efficient way of doing it. But when you're actually looking at the R&D process, I'm suggesting that you can use it for optimization, and I talked about that earlier, but you can also look at it for verification. So whenever you get done, I want to go in and make sure this design process product that is produced is actually going to work in a manufacturing environment. How often have you seen, whenever you've been involved in this sort of thing, it works great in development, but then you put it in production, it doesn't work? Okay, well, if you looked at your design of experiments to make that transition, then that can be very, very helpful with that here. So another one here we got is the die cut process. Looking at he had his response to be operational speed. Okay, so but that's another one here. That's the one he listed here. But I think you also want to probably look at some sort of a quality metric too, because we want to have a balance here. Because you could have increased the speed of it, but you might be affecting your quality. So those are two things that you might want to look at. And then the variables that you might have: the thickness of a mylar, the blade sharpness. See, the blade, that's a good one. You got old versus new blade. You could use a design of experiment with a new blade, but all of a sudden, guess what? The blade's going to wear, and then the process doesn't look at it. So to me, that's a normal range that you're going to be experiencing. And then the thickness of the mylar, however, is how you're going to look at two different ways of looking at thickness. Now, you might have to deal with 5 and 7, or that might be an option that you could go in and say, hey, I'm going to only do this for 5 or 7. So what's the right answer maybe for 5 is not the same answer as it for 7. So that would be somewhat of an interaction. Okay, let's move on to the next one. Request for a proposal for new work. Experiment of producing correlations for the process has 16 variables affecting the output response, reducing time, and so on. Now, in this case here, now if you got, they're talking about here, they got physical parameters for temperature to chemical reactions. Oops. Sorry about that. I'm getting choked up here. The procedures and so on. So whenever you can get at something high and low like they're talking about here, then physical parameters for these temperatures and so on, then the thing is that's a potential shoe-in. Okay. Behavioral attribute, and then also blood test results. Well, this is kind of an interesting one, is what I call, because they wanted to look at the real result is behavior. However, and they're looking at different medicines and so on. But you got almost an interim response too, because now they're looking at the blood test results, and the blood test results might correlate to the behavior attributes too. So it's kind of an interesting one to do in that. So they're looking at different procedures and so on what they might be able to do. Okay, now we're looking at the, let's see, this is dealing with the air freight process for merchandising. So now in this case here, there's a lot of factors that you might be looking at passively. This is dealing with cycle time is the response you're looking at. The assignment methods could do this, and pre-assigned versus Kanban methods. And so as long as you can set them high and low, you're okay. But I would venture to say you'd also have a lot of what we call covariates in this. And it might be better to actually first looking at it using regression type techniques, multiple regression. But then you could go in and also, when you do a multiple regression, instead of the normal design of experiment approach, you could go in and set a factor new versus old procedures. So if you got a lot of covariates in there that you're just observing as opposed to setting, you might just be better off a multiple regression. Now this other one is kind of an interesting, it's accurate reconciliation and reporting of two management books, financial versus sales records. So this is the last one we had here, and when he was explaining it to me, I started thinking about policies, you know, because he was talking about there's a different day of the week or day of the month that they close the books, and then they're trying to hit kind of a moving target here. And I just started thinking, I said, you know, sometimes I think maybe we're trying to do this, but we might be able to change a policy, and the question is, why can't you close both of these financial versus sales records on the same day of the month? Because that seemed like that might fix the problem. Of course, that might be just a naive way of looking at the problem. But first off, make sure you're answering the right question. That's really very important, because sometimes we answer the wrong question in the third decimal place. So just in summary, we went over the why one factor at a time experiments were not very effectively. And we talked also about how you could apply DOE in various aspects of an overall business management system. We also touched on why 2K DOE, that is primarily 16 trials and 32 trials, are probably the best, because 32 trials would have 16 high and 16 low, and 16 trial would have 8 high and 8 low. So that does a pretty good job for most situations. And also it manages the two-factor interactions. And how you apply the DOE within the development, transactional manufacturing processes, and how you develop factors and levels for various situations. So anyway, we're getting close to our hour here, but we are opening up here to have any questions and answer. You gotten anything, Rick?
This one, I'm going to paraphrase it too, Forrest. How long should you take to prepare for a design of experiments? Is it relatively fast, or are they slow? You can interpret that as you want.
Oh, that's a really good question, because you know, it's the devil's in the details, as we say, because a lot of times we've done experiments using the catapults in the class, for example. And I like to use our catapult because there's a lot of different ways of messing it up. And the problem is a lot of times we don't think about how to manage the experimental error, for example, or how we're picking the levels. Maybe where they're too wide or too narrow. And it's very important on how you're actually picking the experiment and setting it up, because often the experiments can be relatively expensive, and you can actually be shutting down equipment. And so you really want to make sure you're doing it right the first time, and actually do some even simulations maybe ahead of time. And that could maybe give you insight to make sure you're approaching it the right way. And I think it's also really important to go in and have somebody else look at it that's had a lot of experience with design of experiments. So it looks like we're about out of time here, Rick.
Yes, thank you again for participating in Forest webinar. There will be a copy again in 2 days. You'll get an email showing you how to access it if you want to watch it again. There again is a survey at the end when you log off. Please take time to answer it. It helps us, and we do go through all of your comments and questions. I really appreciate it. Thank you again for attending.